I don't know the answer to that. And I think you're, so I've heard a lot of those concepts, so there's a sort of slow adoption of the latest methods of machine learning by the brain imaging community. And you'll see in imaging papers when people are starting to use support vector machines, lasso. I mean, good machine learning people say, don't use those, you slow it down. So maybe we could work together on that kind of problem. I think the communities that publish machine learning methods are not always, those papers are not always seen by neuroscientists. So I think there's going to be maybe anything that's good will make its way out. And it's similarly connectivity. Connectivity has only become a very popular topic in neuroscience in the last few years. And there tends to be sort of waves of how these things are done.
So I guess follow up on that question, I think probably is sort of ENIGMA is its exception in the sense that it does have a vast amount of data, whereas typical brain imaging projects is basically data restricted, right? So this is sort of to answer to these complicated learning methods. They don't apply simply because we do not have enough data. So the issue is that we are not dealing with Google, where we have trillions of SS data points, where we have handful. So then these sophisticated learning method, usually you ended up fitting the first, second terms, right? So in which case then you kind of you don't. But this I see this as an exception, right? So this is really the maybe the deep learning method, or it would bear fruit.
Actually, there could be ideas in machine learning that could make use of this data. So let's say you've collected new data. So maybe there was only time or money to scan 20 patients. Or maybe the patients are hard to find, maybe there are only 20. There's a lot of interest in trying to find out how the data already collected could have a bearing on interpreting the data. I mean, obviously, a lot of Bayesian methods, which has worked on MRI and PET. If you have an MRI scan from someone who has a PET scan, you can use it to better interpret the PET scan. So I think one notion is trying to transfer learned information on other people. And I mean, the machine learning community has been doing that for a long time, certainly online learning, where in online learning, it's like on a production line, you're getting samples that you have to classify straight away without any chance to see them in advance or any of them. That sort of notion for small data sets might also be good.
So how do you currently distribute your computations?
Well, we need help with that. So currently, protocols and algorithms are sent to the sites, and it's sort of the stage A we talked about, where meta-analyzed results are sent back to us, and then a separate algorithm is performed to aggregate the data at the end. Now, there are two variants of it that we have not done. We'd like to do it. One is where you generally do share data among the sites to avoid computation. So you always, in distributed computation, want to avoid performing calculations that are not informative because other processes have found a closer solution. So we'd really like to find collaborations and methods where the efficiency is distributed across sites. And certainly the model sharing is possible. The data sharing isn't, because of the reasons that we talked about. So I think as these things evolve, there may be ways that allow multiple computational sites to take part, with some failure tolerance as well. But also more, when the networks were shown, you would ideally have networks of machines sharing models. But in fact, the only way we've been able to do it so far is to have distributed computation come back to one site and then back to the other sites.
How do you distinguish model from data? There is, we worked on problems similar to this, but we had to define what we could not share and what we could share. Completely different from us. How do you define the line between?
It's evolving. So I'll tell you an example. So let's say you cannot share data, but you can share statistical statements about data. Okay. That seems non-inflammatory because you're not identifying an individual. Well, even that has been challenged. And so we wrote, I've got to show you this. So we wrote a tool. This is it. So these are ENIGMA's results, and it's a tool written by Nick Novak at our center, where you can query a gene that you care about and what it does to the brain. And so you can just put a gene in. And this is a statistical summary, and then Jim, you do these all the time, the Genome-Wide Association. A fellow called David Craig wrote a very inflammatory paper. He said, all these people that are sharing statistical summaries of genetic data from aggregates of thousands of people, that breaks privacy. There's a problem with it. I said, well, no, there isn't. It'd be like sharing an average photo of everyone in the room. It would be so scrambled that there'd be no way of identifying the individual. He said, well, no, there is. Because in your aggregated results, there'll be certain genetic variants that are overrepresented versus the average of millions of people. And the degree to which a person's genome has participated in a study can be assessed using metrics. And you can make a comparative statement. So let's say we published on HIV, and we had someone's genome. Even in the aggregated data, and I mean, admittedly, it's a statistical model, it's nothing to do with any one person. So the David Craig paper was interesting because it caused, among other things, NIH to limit the display or dissemination of genome-wide statistical aggregates, unless you signed something that you were not planning to be nefarious. In other words, you and I can analyze a brain image if our ethics board says we're competent, we're not planning to disclose private information. So it reminds me a little bit of RSA encryption. So in cryptography, you always know that a code is unbreakable given a certain space of algorithms. But that isn't to say that there won't be an algorithm in the future that's able to break it. So there's sort of an ongoing dialogue between the privacy folks and the powerful algorithm folks. And it'll be interesting. I think you're right, there isn't really a distinction between data and model. If so much data has gone into building a model that has all the information.
That's a good place to leave it. Thanks very much.
All right.